Somewhere in our galaxy, tucked away in the constellation Libra, there is a star that is older than the universe itself. According to every law of physics we hold dear, this object simply shouldn't be there.
It is a cosmic fossil that appears to predate the Big Bang's supposed timeline, a defiant spark of light that challenges our entire understanding of reality. If this star is real, and it is, then the very foundation of our cosmic history is resting on a lie.
Welcome to Deep Science Explained. For nearly a century, we've believed the universe is roughly 13.8 billion years old. It's a number etched into our textbooks and hard-coded into our satellites. But HD 140283, better known as the Methuselah Star, has spent decades mocking that number. Early measurements placed its age at over 14 billion years. By the end of this video, you will understand how a star can appear older than the space it inhabits. We are going to explore the cosmological crisis, the mind-bending reality of nuclear pasta found in stellar corpses, and the newly discovered black hole stars that James Webb detected just months ago in 2026.
This is the deep science of the impossible, the points where the math breaks and the universe reveals its hidden layers. By the time we're done, you'll realize that the Methuselah Star isn't just a curiosity, it's a warning that our map of the cosmos is still missing its most important piece.
Here's where it gets even stranger. In 2013, a team using the Hubble Space Telescope thought they finally had it solved. They calculated Methuselah's age to be 14.5 billion years, plus or minus 800 million. On screen, a timeline showing a star existing before the Big Bang.
But wait, the universe is only 13.8 billion years old. This is the part nobody tells you. In physics, explained by standard models, you cannot have a child older than the mother. Even at the lower end of that margin of error, the star is practically touching the very moment of creation.
What would it mean if our dating methods for the entire universe were off by 1 billion years? If your brain is rebelling against this right now, you're not alone. On Deep Science Explained, we peel back the math to show you that scientists spent years trying to shrink the star's age to make it fit.
They looked at its iron content, which is 250 times lower than our sun's. This star is so pure that it must have formed from the primordial gas of the very first stars. But even with refined measurements, it sits right on the edge of impossibility.
If this is true, then everything changes. If you've ever felt like we're missing something massive about the nature of time, tap that like button. It helps this exploration reach more curious minds. We are looking at a living fossil from an era that shouldn't be accessible to us.
But if Methuselah is an age mystery, our next star is a chemical nightmare. Meet HD 101065, or Przybylski star. This star is so weird that some astronomers have unironically asked if it was tampered with by an advanced civilization.
Here's where it gets even stranger. Most stars are made of hydrogen and helium with a sprinkle of heavier elements, but Przybylski's star is packed with elements like Einsteinium, plutonium, and promethium. This is the part nobody tells you. These are short-lived radioactive elements. They shouldn't be there.
If you put a piece of promethium in a jar on your desk, half of it would be gone in less than 20 years. For these elements to exist in a star's atmosphere, they have to be constantly replenished. Is the star a natural nuclear reactor? Or are we looking at the trash can of a Type II civilization?
Some have even suggested that an alien species might be salting the star with radioactive waste. But here's the twist. 2026 data suggest these elements might be the decay products of ultra-heavy elements that haven't even been discovered on Earth yet. We are seeing a chemistry that breaks the periodic table.
If this star turned out to be the result of a natural process we don't understand, what else would collapse with our current theory of stellar evolution?
We are searching for why the universe allows these anomalies to exist.
In a few minutes, we'll see why a weird equation regarding dark matter might explain why some stars are powered by a parasite at their core. But first, we have to talk about the most shocking discovery made by the James Webb Space Telescope this year.
In early 2026, JWST identified a new classification of object, the little red dots, or black hole stars. Imagine a star so massive it shouldn't be able to hold itself up. Usually, gravity would crush it into a black hole instantly. But in the early universe, these stars were powered not by fusion, but by a small black hole feeding at their center. This is the part nobody tells you. These aren't just stars. They are cosmic parasites.
The black hole generates so much heat as it eats that it pushes back against gravity, keeping the star inflated like a giant glowing balloon. This is mind-bending science at its peak. We are seeing objects 10,000 times more massive than our Sun, existing in a time when the universe was supposed to be empty.
If this gave you chills, save this video. It's a record of the moment our textbooks were rewritten.
But why do these stars defy our rules? To find out, we have to look at the densest material in the known universe, nuclear pasta. When a massive star dies, it leaves behind a neutron star. But recent studies in 2026 have found hybrid stars that sit right on the edge of becoming black holes. Inside them, the pressure is so high the neutrons are crushed into shapes resembling lasagna, gnocchi, and spaghetti. This is the part that breaks your idea of reality. Nuclear pasta is 10 billion times stronger than steel. A single teaspoon of it weighs as much as Mount Everest. How would your world change if you could touch a material where a single atom was compressed to the size of a city? These stars shouldn't exist because the math says they should collapse. Yet we see them pulsing, stable, and defiant. They are the ultimate proof that gravity has a breaking point we don't fully understand yet. We are the only ones looking at this. On Deep Science Explained, we peel back the layers that other channels ignore. In a few minutes, we'll reveal the perspective shift that explains why these impossible stars are actually the keys to a new physics.
Before we reach the reveal, we have to look at the dark stars. These are hypothetical giants powered by dark matter annihilation rather than hydrogen fusion. If they exist, and James Webb has found 3 candidates in 2026, they would be cool, puffy, and larger than our entire solar system.
They are the ghosts of the early universe. They shouldn't exist in a universe governed by light, but they thrive in a universe governed by the dark. This is the part where everything breaks. If dark matter can power a star, then the luminous universe we see is just a thin crust over a much stranger reality.
But here's the twist. What if the Methuselah Star isn't actually older than the universe, but just the first object that proved we've been counting time all wrong? So how can a star like Methuselah be older than the universe? The reveal is simpler and more profound than we thought. The cosmological crisis of 2026 isn't just about aging stars. It's about the expansion of space itself. We've been measuring the age of the universe based on how fast it's moving away from us, a number called the Hubble constant. But the stars are telling us a different story. The Methuselah Star isn't older than the universe. It's a living fossil that proves our measurement of the universe's age is based on an incomplete map.
If this star is 14 billion years old, then the universe is likely much older, or the Big Bang was more of a slow thaw than a sudden explosion. Think of it like finding a 100-year-old coin in a house that was supposedly built only 50 years ago. You don't throw away the coin. You realize the house has a hidden history. These impossible stars, from the radioactive weirdness of Przybylski's to the black hole parasites, are the coins that prove our cosmic house is much, much older and weirder than we were told.
If this changed the way you see the stars, that's exactly what Deep Science Explained is here for. Tap that share button for the one friend you know who loves to question reality.
You aren't small because the universe is big. You are amazing because you are a collection of atoms that has figured out how to measure the very things that would crush you. Every breath you take is a miracle of balance in a cosmos that loves to break its own rules.
We are living in the golden age of discovery, where the James Webb Telescope is tearing down our old textbooks every single month. We used to think the universe was a simple clockwork machine. Now, we know it's a chaotic, creative, and ancient mystery that we've barely begun to read.
But here is the final question. If we were wrong about the age of the stars, what are we wrong about when it comes to the end of the universe? If the beginning was a slow thaw, is the end a fast rip? And if you think a star older than the universe is strange, wait until you see what happens when we apply this New Age math to the black holes at the center of our own galaxy.
Tell me in the comments which part of this video broke your brain the most, the nuclear pasta or the star powered by a black hole, and why? I read every single comment to see where our community's curiosity is heading.
If your curiosity is still buzzing, the next episode in this series on the dark matter origin is waiting for you right here. The giants are moving. Let's keep watching.